star. So all stars start the same way with the molecular cloud. This is kind of like a big like dust cloud in space of hydrogen and helium atoms. This then becomes an open cluster, which has a bunch of like protostars in it. They're stars that obviously aren't full-grown stars, but they're kind of becoming a star, if that makes sense. Now, from there, that's when this whole thing kind of splits. So sometimes it becomes a brown dwarf. Some people say that that's what Jupiter is. That's wrong. Most brown dwarfs are like 16 times the size of Jupiter. Jupiter is not a failed star. It's just a very successful planet. Now, our sun is a low mass star. So a low mass star is anything that's less than 8 million suns. So obviously the sun is included in that. Those eventually become red giants. They expand, they gain density, and yeah, they become a red giant. Now, these can turn into one of two things: a planetary nebula, if it kind of like explodes. Like, not explodes, that would be a supernova. Kind of just slowly disintegrates. That's definitely not the word, but disintegrates in a sense. Now, red giants can also become like a binary white dwarf. So something comes off of the red giant, and now a red giant and a white dwarf, which is like a cold star, start orbiting each other. Now, this can go into a type 1 supernova, which is when the star explodes, or just go into a nova, which is just less dense than a supernova. Not less dense, like less explosive than a supernova. Now, this nova can either go back to the binary white dwarf stage and then keep on going and in a loop, or it could turn into a white dwarf again. No matter what, it's turning into a white dwarf. It's just about whether it'll be orbiting a different red giant. Now, the nova wouldn't turn back into a red giant, but it would create a white dwarf that could then end up orbiting a red giant. So the nova turns into a white dwarf, and this ends up being a black dwarf, which is like a very cool star. It's just, and by cool, I mean cold. It's literally the remnant of a star. The star's not alive anymore. Now let's go to massive stars. So massive stars are bigger than 8 million stars. Wait, no, bigger is a bad word. Dense, more dense. 8 million times the density of the sun or bigger. Now, not bigger, more dense, sorry. The massive star could then, will stay there, like its main life stage, and then eventually it'll become a red supergiant. It'll expand and boom, get bigger, red supergiant. This will eventually explode into a type 2 supernova, which is really big. Like we saw a type 1 supernova before. This is type 2. That's a lot bigger. Now this can either just turn into a supernova remnant, also known as a nebula. You've heard of the Eagle Nebula or something. Or if the type 2 supernova was less dense than 40 million suns, it'll turn into a neutron star, which are these stars that spin very, very fast, which can turn into a pulsar, which has the little beams going, you could see there, and still going very fast. Now, if the type 2 supernova is more dense than 40 million suns, it'll turn into a black hole, which we all know as the big things that'll travel and suck things in. That's completely wrong. You would have to get near a black hole in the event horizon in order to get sucked in. You can't just randomly get sucked in if you're nowhere near the event horizon. Now, this black hole will eventually turn into the X-ray emission. So it's still a black hole. It doesn't necessarily turn into the X-ray emission, but it lets out a bunch of X-rays. You've heard of X-rays, medical, but these are X-rays, kind of like microwaves and X-rays. All right, anyways, that's it. The stellar life cycle. Bye.